packet pushers.
Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Nick Baraglio. We discuss everything IPv6 on the show, from strategy, design, deployment, operations, and even internet standards.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We work on getting IPv6 working.
And we're here to share some lessons learned and how to avoid common mistakes. We're glad you joined us. Today, we're going to continue our IPv6 Basics series, and this time we're going to be talking about routing. Finally getting around to a topic that probably a lot of folks have been expecting. So let's just jump into it. I guess the biggest thing would be talking about differences in what routing protocols are supported in V6. So maybe we start there, just in terms of the basic strategy for folks. They're probably, many shops are probably running OSPF, or they're running, maybe if they're a legacy Cisco shop, they're running EIGRP. Many folks are probably running BGP in some capacity. So let's just break down routing protocols and talk about what's supported in V6 and what isn't. So who wants to take on the list?
I mean, if you're brand new to the whole domain, you may be relieved to hear that there aren't any unique IPv6 routing protocols, unless you're running a low power lossy network and have to use Ripple, but that's a topic probably for another day. So yeah, if you're already familiar with EIGRP, you're already familiar with OSPF, BGP, of course, whatever routing protocol you're familiar and comfortable with, there's a version of it that supports IPv6 and pretty broadly across most platforms, so that you're not having to reinvent the wheel when it comes to routing IPv6.
Yeah, I guess the old school, back in the day when you were learning your V4, probably the first routing protocol you learned was probably RIP.
That's right. And with any luck, RIP v2.
And that is reflected in IPv6. There's a RIP NG. So it's back in the day when IPv6 was called Next Generation. So the RIP protocol took on that namespace. So RIP NG is what's utilized in IPv6.
We shouldn't neglect to say how cool that sounds. And then, of course, how cool it kind of actually isn't, because it's RIP. But RIP NG, RIP NG, RIP Next Generation makes it sound pretty adventurous. But you know what? It still has applications, right? I mean, there's still scenarios where you might imagine using RIP NG.
I have used RIP NG in production.
There you go. I knew it.
It's the first real routing protocol that a lot of people that are of our vintage probably ever played with. You turn it on, it just does its thing, right? Routing by rumor, it's just there. It operates pretty much exactly the same. But I think one thing that, sort of caught me when I was doing V6, when I started learning V6, I was at a service provider, right? And service providers typically routed IP, right? However, the places that I had come before that, now I'm dating myself, and this is a concept that I learned very early on that other engineers of later vintages probably never had to learn, was that, before I was routing only IP, I was at places that routed IP. IP was just one of the things that got routed, right? There was Apple Talk, and there was a lot IPX, SPX, right? Because large Novell netware constellations in a lot of enterprises, that's what I use. And then you may have other sort of fringy things like DECnet and some other SNA, other things in there, but the concept of it being just another thing on the wire, I think, changes the way that you think about routing, right? Because those things are just ships in the night and they don't know that the others exist. And that's sort of the concept that you have to think about if you're moving from single stack IPv4 to dual stack IPv4, IPv6, is that now you have these two things that they don't necessarily know that each other exists, from a routing domain, but you need to, as an engineer, you need to understand that, they both exist on the wire, and that because they don't necessarily know that each other exists, they just coexist together, their topologies might be different. I realize I went way into the deep end really fast there.
Well, and then, of course, you can get into the weeds and find yourself in a bad place in that regard, because there are ways in which you can configure some of the routing protocols so that there is fate sharing between the address families in a way that it would be probably more optimal for a lot of network environments if they are truly ships in the night and they're truly different SPF calculations and truly separate link state databases and that sort of thing. But it gets kind of muddy depending on what routing protocol you're looking at and how it's configured. You can end up with single topology mode where IPv4 and IPv6 are sort of stuck in the same boat together, as opposed to being ships in the night.
Yeah, ships in a lane.
Yeah.
Now we're talking about ATM.
Yeah. But besides RIP, getting back to our original sort of breakdown on protocols, I mean, I guess the other next obvious one is OSPF. OSPF version 2, OSPF version 3 is what we utilize for V6. So I think for the audience, version 3 is what you would use for IPv6. You would run both version 2 and version 3 more than likely in most scenarios. It is possible, as Tom just mentioned, to run sort of a combination. I don't know if I would do that for OSPF, but you can get yourself in a bit of trouble. And not all vendors are supporting sort of that combined mode for OSPF, which means that you might even have additional problematic configuration and topology issues to work through because of the type of peering that you want to set up. And so for that sort of configuration, typically normally just recommend that OSPF version 3 run on its own for IPv6 as a dedicated routing protocol. And more than likely, you're probably going to set all your cost factors for your interfaces the same and do all the work so that the topologies actually match, even though they might be running 2 instances of Dijkstra. You're going to be having different sets of calculations based off of the fact that a link may or may not be going up or down at any given moment in time, but the two would be running in parallel to each other. And I guess this is a good time to sort of mention this. This is where the cost of running dual stack becomes more expensive because you're obviously running 2 instances of Dijkstra. You're using more memory for hosting routing protocol, state tables, etc. Everything down the road, you're just using more resources to make that happen. That can be a negative, that could be a downside, depending on what your resource requirements are within your given network. So there, we click out to RIP-NG OSPF version 3. I guess the next logical one down the list, maybe we hit BGP next.
Or do we want to stick with the IGPs and talk about ISIS?
We can talk about ISIS and then EIGRP if you want. Yeah, I mean, ISIS is interesting because it's maybe a next logical extension of where OSPF comes from, right? In terms of just routing protocols. And well, maybe enterprises are going to see more ISIS over the intervening years here. It seems to be gaining a little bit in popularity in terms of use cases. And certainly, behavior-wise, there's some conveniences for IPv6 in regards to how ISIS behaves. And back to Tom's point about single topology mode versus multi-topology mode configurations, ISIS is, I guess, a primary example of one that gives you the ultimate flexibility to sort of set it up any way you want or any way that might mess up your network, depending on what you're up to. So I guess we could break it down a little bit. I don't know. Does it make sense to talk about the difference between single topology mode and multi-topology in terms of what ISIS thinks about stuff? Because it really doesn't care as much about the IP protocol portion.
Right. Or layer 3 for that matter.
Before we go into that, the reason I brought it up is because that's what I work in most of the time. I'm much more familiar with that at this point than I am with OSPF. One of the bigger advantages is ISIS has, I consider to be an advantage or a difference. Let's just call it a difference, right? Because it depends on your perspective. One of the differences is that it doesn't care. The routed protocol is essentially, it's a TLV. It's a plugin for the routing protocol. So it can carry whatever you want it to carry. It carries v4 as a TLV. And then you can add IPv6 into it. You run one instance of it, essentially. That and its scaling are sort of the two, I think, big differences than from OSPF. You don't necessarily historically see a lot of ISIS in enterprises. They typically are more OSPF shops. ISIS, because of the scaling, tends to be more of the, service provider based protocol.
There's a little bit more flexibility with ISIS in terms of topology configuration, right?
Oh, for sure.
Mm-hmm.
OSPF is limited to that area 0 construct, right? And so we have to do all sorts of weird things to break out of that. And I'm not going to cover any of that in this show because it's not specific to v4 or v6, right? That's an OSPF property.
Yeah, and also I think there's a In Is for Networking podcast that goes into some detail about that.
I do think it's worth backing up from that, avoidance of getting into the detail and the weeds related to ISIS versus OSPF, but just asking the question from an architectural standpoint, what are you trying to accomplish regardless of whether it's v4 or v6? So like from a design perspective, there's nothing really compelling about any of the differences that would necessitate picking one over the other because you're using v6. Rather, if you're in an enterprise environment where you're considering going to OSPF, or you're considering going to ISIS from OSPF, you probably have very specific reasons related to your architecture and how you're managing your topology. And that should be sort of decoupled from the address family question of, is it IPv4 or IPv6? Because how it's configured and how it's actually going to operate under the hood, there's really just not enough of a difference to really talk about. So yeah, I think we deal with a lot of enterprise shops. And I think there's always that sort of question that they're aware that they've gotten over the first hump of there's nothing unique about the routing protocols where IPv6 is concerned, but they're not really over the second hump where it's like, well, do we use IPv6 as an excuse to make architectural or topology changes that, we've been putting off in v4, for any number of reasons. Complexity, of course, the first of them, probably the risk of renumbering and the pain associated with that. But I think that's something that, as a sort of abstracted meta question, is the bigger and more important point. Why are you choosing the routing protocol that you're choosing? What problem is it solving for you or not solving for you? And, is there an advantage to moving to a different routing protocol, regardless of whether it's a v4 or v6 topology?
Right. I think a lot of people use V6 as that opportunity to make that change because of the fact that you're having to go through a pretty major transformation network change anyway. So they're using that pivot to go ahead and do that. But I agree, it should match what your design requirement needs are from a routing protocol basis and not necessarily about what address family you have anything to do with.
Yeah, I agree with that. I've seen that happen, where that's been used to change over from OSPF to ISIS. Implementing V6 is, sort of the catalyst for that. But I think that, at the end of the day, what you should use is sort of what solves your problem that you can support and afford.
I've seen something similar from EIGRP to OSPF, just from moving from a single vendor supported routing protocol to something more universal standards based, simply just to be able to get away from sort of vendor lock in related to that. I understand EIGRP has changed in terms of that, and there's open standard support for it, but that doesn't mean that everyone's developed it or has support within their product family to do anything with it. So,
but it's still surprising to me that we do go into enterprise shops, big enterprise environments, where EIGRP is the hill they're going to die on, and not without good reason, based on their experience with it and how they operate it and use it. So
yeah, it's still the best for DMVPN. I'll concede to that one. It's better than BGP. It's better than OSPF for those particular design considerations, at least in my humble opinion, for someone who's deployed a lot of it.
I'll use this as a fess box here and confess that I've literally never used EIGRP outside of like when I was studying some of the Cisco exams 20 plus years ago. Never used it. Couldn't even tell you how to configure it.
It's a pretty very straightforward. One of the things that people really love is it's a 2 command line option to turn it on and get it working.
Summarization on the interface is really powerful too.
Yes, that is the thing that everyone really loves about EIGRP.
That is cool.
So it definitely has its advantages in terms of how that works. So, but we can leave the diatribes around the advantages for EIGRP to Russ White and company to chat back and forth and figure that out. But I guess this is a good time as any to just mention that EIGRP does support IPv6,
right?
Just as EIGRP was always designed as a multi-routing protocol positioning tool for Cisco to be able to get into the market for routing everything, right? SNA, IPX, SPX, IP. It supported pretty much everything across the board, which I think was one of the advantages of it very early on in its development. And so I think that's one of the things that's sort of unique about it out of all the routing protocols that we're sort of chatting through. But yeah, you can totally do V6 with the EIGRP. Yeah, I don't even think they do a version number for differentiation. I think it's just EIGRP and that's it.
Your V6 routes can be stuck inactive just like your V4 ones can.
I guess that leaves us on the workhorse of the internet, right? Which we trickle down to BGP, and
which many have argued is not even a routing protocol anymore. It's just an application, right?
It's a standardized interface application for data exchange.
Yeah. What a Greg Farrakall always called it, garbage can of the internet. You just throw everything into BGP.
Yeah, we can make new extensions. BGP MP, right?
Yeah, that's right. He said you wanted extensibility. Here's your extensibility.
Here it is.
Who wants to drink from the fire hose?
As you probably have all figured out, V6 works just fine over BGP. There's some interesting combinations of things that you can do with BGP because you can pass V4 routes across V6 links. You can pass V6 routes across V4 links, V6 routes across V6 links, V4 routes across V4 links. It's a pretty flexible application to be able to do this sort of stuff. And fundamentally, I don't see people doing anything strikingly different around BGP, V4 versus V6. I think the standard behaviors and patterns that you use for BGP today for IPv4 match a great deal in terms of what you do with IPv6. Maybe the core sets of differences have more to do with maybe a more thoughtful address plan. So it might change your perspective of summarization. It might change how you tackle bogon lists and things of that nature. But those are more operational issues than design issues, I would say. And so I think just in terms of behavior-wise, BGP is going to act like BGP, and you're not going to be super surprised by what you see. I think that's a fair statement.
I think that's all correct. There's the additional wrinkle maybe of dealing with link local addresses as next hops. And, BGP, you can always get wrapped around the axle with next hop, fun with the next hop, where it is, if it's reachable, that sort of thing. And then how you're going to manage your configuration based around, in V4, you don't think about it because it's just a V4 address on the opposite end of the link. With V6, you have to be cognizant of the link local address and what you're using to peer with and what the next hops are set as a result of that.
That's also true. That actually just brought up a thought in my mind that for protocols like OSPF, when you're doing V4 or OSPF V2 for IPv4, you have to have addresses configured, on the point-to-point links, and they use the protocol that they're routing, essentially for communication, right? With V6, you can do it only with link local with OSPF v3. And I've actually renumbered a wide area backbone in the middle of the day, the V6 part of it, and no one even knew it happened because no adjacencies flapped. It uses link local for all of the communications. And those V6 addresses that are added to the point-to-points that you see, they're essentially there for troubleshooting purposes and to make them show up right in traceroute, things like that. That's a distinct difference, I think, is that, the link local addresses they do have a significance in certain ways. Like you said, Tom, they can also bind you up a little bit if you've got next hops that aren't right, or, you just have to understand the nuances there.
I guess we could shift gears and talk a little bit about the second attribute about routing, which is building routing tables, right? And saying that you're going to see link local addresses in your routing tables for the mass majority of these routing protocols. And because link local is a legitimate next hop for many of them, you're going to see next hop link local addresses. And there's probably tips and tricks and techniques that you can use to be able to make your life a little bit easier in terms of understanding where traffic is actually going, maybe embedding things like router IDs or some other useful piece of metadata related to the link local addresses, which is why you might want to actually set up your link local addresses explicitly versus just letting them build UI64 or Slack in some manner.
Yeah.
To get a little bit more metadata that helps you sort of determine where traffic is going. Although obviously you can just look up your neighbor peer and, sort of determine what's going on there. And then I guess secondarily, there's some other common routing attributes that folks use around ACLs to be able to filter stuff. And I think the other common one that I see that's in use is sort of on the Cisco side is some sort of more complex inverse masking, right? And that stuff just really doesn't exist in V6 in any practical way. That you can make use of it. Although I've heard rumors that there's plans to try and make that stuff available, but I haven't seen any implementations that actually make use of that. So just realize if you're doing sophisticated routing stuff where you're actually using inverse mask for the purpose of controlling routes, may not be a tool in your tool belt in the same way that it was in IPv4. I haven't seen a lot of people do that recently. I think V4 address space has gotten so bifurcated with and split up that it's not as easy to do some of this type of summarizations that we typically see.
Yeah.
As being more useful. And so you end up writing ACLs that are a lot more specific around, end node addresses versus necessarily weird octet configurations to try and figure out who's doing what where. But, V6 isn't going to be reflected in the same way. So I just make mention of that. It's obviously not a routing thing per se, but it is something that's sort of routing adjacent, right?
Well, and sure, and especially with BGP, where you're doing a lot of prefix lists and a lot of route maps and that sort of thing. You really need to know what the options are in terms of how you're filtering things. And I mean, it's not like back in the old days where you had to do reverse masking to really drill down on the BGP prefix lists and greater than, less than flags make it pretty easy to get granular with that stuff now and with minimal amount of configuration. But it is a consideration. And to your point, yeah, we just don't have inverse masking or wildcard masking in V6. I hope they don't re-add it. Please.
Yeah, please don't.
Please, let's keep it simple. That's right. And then consider off into the distance, please.
I've heard some rumors that there's consideration of writing code to do that.
Well, they should keep considering and then decide not to.
Yeah.
Yeah.
Yeah, well, I don't know what Nick's complaining about. I'm sure he can write some Perl that does the same things.
Oh boy. Hey, I wrote some C the other day. Another thing that I think is maybe important from the routing perspective is that since we're talking about BGP, there's a big move to, make BGP more secure and, have it be more deterministic and standard across the way people are operating and implementing it. And, the tooling out there to do that for things like building prefix lists or route maps or what have you off of the IRR data, those exist for V6 as well as V4. So tools like BGPQ3 and, some of the other tooling that you use to the IRR toolkits and stuff like that, they're sort of mostly agnostic that, they just pull the things out that are reported in those public databases and they can build the protocol that you ask for. Those things exist. So if you're used to using those for V4, say, you're new to V6 and you need to turn it up for your company, but you also control the BGP, you can use some of those existing tools like you've already been using them. It's nice that way that you don't have to go and do something different. It's all pretty uniform across the board as far as the routing toolkits go for building that stuff and automating it.
Yeah, that's a good point. I guess secondarily, we should also mention that the routing registry components and the new signing stuff, V6 is fully supported in all of those from all the RARs. So if you need to do the announcements and control whose AS is advertising what prefix, and you want to have it signed and you want to have all that other goodness, you can do that for both V4 and for V6. It's supported for both. So it's not like there's anything weird going on where V6 is the more Wild West than the V4 side or vice versa. So
no, it's pretty uniform
Yep.
across the board at this point, which is really nice.
I guess just to get into just a little bit of the configuration detail around BGP for folks that are super new to it and haven't turned up any V6 peering sessions and that sort of thing, there's a lot of address family verbiage or
good point.
well, it's maybe tricky to navigate the first time you're dealing with it, and like thinking specifically in a Cisco environment and sort of the hoops you have to jump through to activate V6, versus not activating the prefix in V4 that you're peering over, that sort of thing. Just the configuration gotchas that sort of exist there. But really, I'm thinking more of the higher level, which is, you have the option, as you mentioned at the outset, when we first started talking about what we haven't actually even named, which is multi-protocol BGP, right?
Yep.
You have the option of V4 carrying your network layer reachability information for either protocol inside the other protocol.
Right.
But we should really put it out there very assertively that you don't do that typically. I'm not taking my NLRI in V6 and stuffing it in V4 or vice versa. I'm avoiding the sort of fate sharing that might come about from that if it's not properly planned.
Yeah.
Because there's no benefit just having a standalone peering session that's over V6 where all the NLRI is carried for V6 is carried over V6 and vice versa for V4. That's the preferred configuration, as far as I've seen it. And I wouldn't want anybody to get sort of wrapped around the axle trying to guess what they're supposed to do when they've got all these address family options.
Yeah, that's a good point. Keep it simple, stupid is still a good principle.
Yeah. And as someone who's kind of gone through that, like, I'm like, I want to carry everything in V6 and I've done it, right? I put it all back, right? Because at the end of the day, I want to have those isolated. I want that failure domain to be small. The shininess of doing it any other way didn't outweigh it.
I always look at it as an operational consideration. If you can leave the V4 skill sets and expertise the way they are so that they understand everything they're looking at, and also within the configuration files of the devices they're managing, if they're only touching the V4 related portions of it, you're reducing your exposure for failures and errors versus if they're having to work inside of V6 with V4 inside of V6, they're still working inside of V6. They can make mistakes within that V6 portion and then potentially bring down both sides, which is problematic. And you're introducing more risk for little gain from an operational perspective, I think is probably the principal portion.
Absolutely.
To Tom's point, you need to design and think about this. It is a little different. Dual stack is going to be a little different for certain use case scenarios. You may be sharing the exact same circuit from a L1, L2 perspective, but you're running BGP peering for V4 over it and then a separate BGP peering for V6 over that exact same link. Perfectly acceptable, assuming that your provider is willing to set up and configure it that way. You might be forced to do something differently depending on what they do or do not support. And you don't necessarily have control over that, which is why you have as many geek knobs available to you in BGP as you have, is because of those use case scenarios. And just realize that probably the standard is let's keep them separate. Let's run them as two separate ships in the night so that we understand what's going on. And the fate sharing is really down at the link level of like, okay, the interface is either up or down, layer 2 is either up or down, and that determines whether our circuit is either up or down, right, at any given moment. And I think that's probably not that the show should really be about best practices, but I think that fits in the category of probably some good hygiene best practice around IPv6 for routing anyway, for at least building BGP neighbor peers. And that probably holds true for pretty much any of the routing protocols across the board. I would probably do that, something similar.
Yeah, it also gives you the advantage of, since they are separate, like if you're thinking about it from say you're not an enterprise, say you're a service provider, and you want to do something eventually like IPv4 as a service, when all of those peerings are separate, they're very easy to shove into an L3 VPN and it just becomes
virtualized.
Yeah.
Yeah.
You create an overlay that's only v4 and everything under it is what's carrying it is v6. It allows you that flexibility of, the modularity. But something else that you brought up, Tom, is that in certain platforms, if you're new to it, the show command structure may be slightly different. If it's an older platform where v6 was added to a legacy code base,
Yep.
you may need to add the IPv6 or IP6 or INET6.
And nor is it consistent about where that appears within the list order.
That's what I was getting at, is it may not be the same per protocol. It may not be the same per different show command within the same protocol.
Yep.
So you may have to use, question marks your friend.
Yeah, context sensitive help is definitely your friend.
Yeah.
Don't expect it to save you from, we've all sort of ingrained the fact that the parser and like a vendor like Cisco and iOS is trying to accommodate sort of the OSI model in some ways, like try to keep your order of commands related to where in the stack you kind of are. And of course that breaks down with v6 because it's like, dude, does the BGP come first or the v6 come first? And I can't remember. And every time I look it up, I forget like 30 seconds later.
And that's why you write shortcuts.
Yeah. And then one of your boxes is XR and it's totally different than all the other ones.
Yep.
Yeah.
Let's not even dive into NXOS. So
we're talking about routing, obviously, but don't get us started on talking about where the flags and router advertisements are all hidden.
Oh, yes.
What context you have to be in to turn one flag off or another one on. It's oh my God, I have to look it up every time.
Yes, it's a good point. Well, I think we covered the major items for routing protocols. I don't know if there's any other highlights that we want to talk about for dual stack environments. Is there anything else that we think is?
Not necessarily dual stack, but just to the question of what routing protocol you should be running in v6. And we mentioned, you may be looking for an excuse to go from OSPF to ISIS. I don't hear often of people going in the other direction, but I guess anything's possible. But something that we didn't mention explicitly, maybe enough, is that there's definitely the advantage of working with the routing protocol that you're most familiar with, And so if your shop is like really steeped in OSPF, that's what and that's, all of your troubleshooting chops are really built around that. There's a lot of inertia there that would potentially prevent you from moving to a new routing protocol. And IPv6 wouldn't really be a good reason just to do it. It's like, well, we're going to do it just because we're moving to IPv6. It's like, well, you're going to be starting from scratch per se. A lot of the same general concepts apply, but we all know what it's like. It's like you're familiar with what you're familiar with in your operating environment and how much more efficient that is at troubleshooting and getting to the bottom of problems and that sort of thing. So I just wanted to make that additional point. It's like you're not moving to a new protocol just because of v6, especially if you're getting an operational benefit from what you really know well and what you can troubleshoot really well, and v6 isn't going to change that.
Very good point. Since we're talking about routing, do we want to talk about, especially in dual stack environments, TCAM considerations for if you're going from single stack to dual stack, what you need to remember about, hardware resources?
Yeah, we can certainly bring it up. I mean, it's something we've mentioned on previous shows, but I think it's good to sort of highlight that dual stack does cost you more from a resource perspective, and it can cost you in terms of real world physical capacity within a platform. And obviously, your routing tables have to get populated someplace in order to make forwarding decisions. I think your FIB impacts are going to impact what your TCAM looks like within a given platform, assuming that it's hardware accelerated forwarding, right? That's going on, and you're not just dealing with a giant software router, which could care less because that's just memory at that point. So yeah, if you are making use of TCAM or whatever the next hardware replacement of TCAM is, I can never remember the name of it, but there's a next generation of sort of memory structure that's designed to replace TCAM. And yeah, you need to be aware that the fact that automatically IPv6 is going to chew up 4 times as much memory just to store a singular full address than a v4 address. If we assume that we stop at a /64 boundary, which is one of the reasons why we advocate for 64, you're still using twice as much. And assuming that you have pre-allocations, most of the manufacturers have pre-allocations that they do. The moment you turn on v6, it's going to pre-allocate a certain amount of address space in order to try and build some efficiencies into how it distributes stuff. And then you have to go in and decide if that allocation, that assumption they made is accurate for your environment. And then the other thing is, if you actually go from dual stack to single stack, are you going back and recovering your TCAM? Or did you leave it, configured as a mixed mode IPv4, IPv6, and you didn't switch it back to v6 only and give you all the capacity back that you really need? I don't know. What else do we need to talk about? I mean, it's just a shared resource. Even though it's ship in the night from a routing protocol's perspective, you are stuck sharing memory, right?
Yeah.
Yeah, that's really what it comes down to.
Yeah, I wanted to bring that up. This is probably not really an issue as much anymore, but on older platforms where, you would enable IPv6 and you'd start taking routes, the error mode when you would essentially run TCAM out is like one log and then you never see another log again. And there's a cryptic command to check to see if it's been, in violation, just, performance stinks. So I just wanted folks to realize like, hey, when you're adding something in, you also need to understand that you're sharing now.
Yeah. And best I understand, you can't control the discard eligibility that goes in for the TCAM. It's just pretty standardized. It's like oldest is purged first and relearning is required after that. And that's what ends up. So you could have a tremendous amount of churn, especially if you have environments that have a lot of clients that are changing over.
Yep.
Dramatically. I mean, if you've got a pretty fixed set of assets in a data center or something, even with TCAM constraints, you're probably going to be, maybe okay, but you definitely want to check and do your homework and make sure if you're above 50% utilization on your TCAM today for IPv4, the moment you turn on IPv6 and want to support the same number of routes, you're going to run into problems, right? So
Yeah.
that's just a given. Because you're going to have the same number of hosts. So you're going to be dealing with the same structural space. So just realize that you want to sort of optimize around that. And that's a really good point. I don't know if there's any other gotchas that fit in there, except for maybe logging and maybe really mentioning very, very quickly, won't go into details, feature parity versus functional parity. You don't have to worry about getting your log files directed over IPv4 or IPv6. I don't know if that really matters because they can both carry, v4 related routing topology information, v6 related routing topology information, and logs and errors and et cetera, right? So for the most part, you're going to have functional parity sort of across the board for what you need. And if you really need feature parity, most of the routing protocols have full feature parity today for everything that you need to do. So it's not really an issue. So just for those that are nervous or trying to figure that out, that's something that you can sort of check off the list and not be as nervous about. Definitely still check in the lab, make sure it performs the way you want. You should always be checking everything in the lab anyway. You shouldn't be trusting us just from listening to us on a podcast. What the heck do we know?
Yeah.
But yeah, that's one of the things I would also mention. All right, let's wrap it up, you guys. Favorite routing protocol and why?
Well, I'm not going to say it's Ripple because I haven't really used it.
It's the most widely deployed routing protocol, though, right? I think it's the most widely deployed routing protocol that no one knows about because it's just used in massive mesh networks, right? So.
And I'm not going to say that we've got the EIGRP advocates out there. I'm going to disappoint them. Nothing wrong with it. It works really well. I'm not going to say OSPF. Could maybe say ISIS, but I'm going to have to go with BGP and multi-protocol BGP.
Okay, so Tom chose an application.
Because it freed us from the tyranny of just routing.
Nick, what's yours?
Oh, I'm going to go the same because I can run it as an IGP. I can run it as an EGP. It carries everything I want it to carry. And I know it the best. So I would go with BGP.
Tom and Nick are into the multifunctional tools. I'll just stick with my single hammer that works really well. I'm still enamored with what EIGRP could do. So I'll say it's still a super useful tool for folks that are in that camp. And if they can actually get more wide common support, I think there's a bunch of use cases where it actually works insanely well for enterprise deployments. So I'll just leave it there. But
all right.
Especially after suffering from so many OSPF outages for Area 0 problems. Living through those. All right, everyone, thanks so much for joining. We'll catch you in the next one. Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or follow-up on this topic, send us a message at packetpushers.net/FU, where FU stands for follow-up. We'd love to hear from you and continue the conversation.
Also, at packetpushers.net, you'll find a range of other deep dive technical podcasts for IT pros.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a community Slack channel where you can talk with industry peers and experts. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long and until next time, we'll see you on the IPv6 internet.